Hello everyone. In this video, I am going to talk about the naming of compounds. Before starting to learn how to name a compound, we need to have some prior knowledge about chemical formula, so let us have a brief review on that. First, what is an atom? An atom is the smallest unit that defines the chemical elements. Then, as you can remember, atoms have close friends called ions, so how do they differ from each other? The difference is that an ion is an electrically charged atom or groups of atoms. And we know charges can be positive or negative. Cations carry positive charges, while anions carry negative charges. Second, there are two terms that you must know before we start the discussions on naming of compounds. The first term is monoatomic. Monoatomic is a state in which elements exist in the form of single atom. Common examples of monoatomic species are atoms, such as sodium and magnesium atoms. There are ions that exist in the form of monoatomic state, such as a Cl- and Al3+, they are called monoatomic ions. Do not forget that there are molecules that are also monoatomic. All noble gas are monoatomic, like helium and argon. Since they exist in monoatomic state, they are called monoatomic molecules. The second term that you need to know is polyatomic. Polyatomic is a state in which a species is composed of two or more atoms. There are polyatomic ions and molecules. Examples of polyatomic ions include NO3- and SO42-. Note that ANO3- is an anion carrying one negative charge overall, while ASO42- is an anion carrying two negative charges overall. For polyatomic molecules, common examples include carbon dioxide, which is CO2, and water, H2O. They are composed of more than one atom. Then, we have to know the meaning of chemical formula. Chemical formula is a way of expressing information about the proportions of atoms that constitute a particular chemical compound. In other words, when I read a chemical formula, I will know the identities of elements that constitute the compound, and the ratio of atoms inside the compound. As a result, a chemical formula commonly consists of chemical element symbols and numbers. Let us have a closer look on ionic compounds, which are expressed with chemical formula. In an ionic compound, there must be cations and anions. Take sodium chloride as an example. In sodium chloride, the cation is sodium ion Na+, and the anion is chloride ion Cl-. Since the ratio of Na+ to Cl- is 1:1, so the chemical formula of sodium chloride is NaCl. You may wonder how I determine the charges of an ion, which is formed from an atom. Then we can find the answer from the periodic table. For ions formed from group 1 atoms, they usually carry one positive charge, 1+, then 2+ in the case of group 2, and 3+ in the case of group 3. For ions formed from group 5 atoms, they usually carry three negative charges, 3-, then 2- in the case of group 6, and 1- in the case of group 7. So, at this stage, we have covered the prior knowledge that we need to know before starting to learn the naming of compounds. In the second part of this video, I am going to teach chemical naming of compounds. Notice that only the chemical naming of ionic compounds and binary compounds will be discussed in this video. If you want to know more about the naming of other compounds, such as organic compounds, you can watch the corresponding videos. First, I will talk about the naming of ionic compounds formed from simple cations and simple anions, which I call it the naming of the first category of compounds. Here are some rules. Cation is always named first, and the anion second. For cations, simply write down the name of the element. For anions, take the first part of the element name and then add the letters IDE at the end. Finally, combine the names of the cation and anion. Let us do some drilling exercises. The first one is Na plus Cl. The first step is to figure out the cation. Obviously it is sodium in this case, Na+. For anion, it is Cl-. So, first write down the names of the elements, sodium and chlorine. In the next step, for cation, simply write down the name of the element, which is sodium. For anion, take the first part of the name of the element and then add the letters IDE at the end, so we have chloride. Finally, combine the names of cation and anion to give the chemical name of the compound. We then have sodium chloride. Remember that there is a space between sodium and chloride. They are two words. Let us have one more exercise. Ca plus O. The first step is to figure out the cation, which is calcium, Ca2+. The anion is oxygen, O2-. Cation has the same name as the element, so we have calcium. While anion will take the first part of the element and add with IDE at the end, so we have oxide. Combine the names, we will have calcium oxide. Up till now, we have finished the discussion about the naming of ionic compounds formed from simple cations and simple anions. Then we are going to talk about the naming of ionic compounds formed with metal ions, and the metal ions can have the possibility of being in different states, carrying different charges under different conditions, which I call it the naming of the second category of compounds. One of the examples is iron. The chemical symbol of iron is Fe, and it can be Fe2+ or Fe3+ under different conditions. Therefore, it is important to specify the charges of the metal ions in a compound to avoid any confusion. In other words, without the specification of charges, we will have no ideas about the charges of the metal ions. The rules of naming such compounds are listed below, which are similar as the above. Cation is always named first, and the anion second. The cation is the same as the name of the element. But we now have an extra rule. A Roman numeral is included right after the cation, to indicate the charges of the metal ions. For anions, the naming is the same as the above. Take the first part of the element and add IDE at the end. It is time to have some drilling exercises. The first one is Fe plus Cl. Fe is the chemical symbol of iron, and it is known that Fe carries two positive charges in this exercise. The anion is Cl-. Therefore, we write down the name of cation, which is iron. To specify the ion carries two positive charges. We add a bracket, and then write down Roman numeral 2. For anion, we will have the first part of chlorine and IDE at the end, so it is chloride. Combine the names, we have iron 2 chloride. And the same as the above, there is a space between cation and anion. They are two words. Let us do one more drilling exercise. This time is Cu plus O. And it is given that the copper ion carries two positive charges, Cu2+. and the anion is O2-. Therefore, write down the name of cation, which is copper. For anion, take the first part of the element, and add IDE at the end. Since 2 plus is the charges carried by the copper ion, so we add the Roman numeral 2 after Cu. Then we will have copper 2 oxide as the name of the compound. Remember to add a space in between. We have now finished the discussions on the chemical naming of compounds involving simple cations and simple anions, as well as the metal ions carrying different charges or states. Here we come to the discussions about the naming of the third category of compounds, compounds that do not contain metal atoms. Some common examples include carbon dioxide, CO2, and water, H2O. The rules are listed and are similar to what we have discussed. However, the first element in the formula is named first, and the name of the element is written in full. Then take the first part of the name of the second element appeared in the formula, and add IDE at the end. Also, prefixes are added to denote the numbers or ratios of the particular atoms present. In other words, we will know the numbers of atoms present in the compound as denoted by prefixes. The last rule is that the prefix mono is not added for naming the first element. So what are the prefixes? If the compound contains one atom of that specific element, the prefix is mono. 2 atoms of that specific element, write di. 3 atoms of that specific element, write tri. 4 atoms of that specific element, write tetra. It's time to have some drilling exercises. I guess that all students have known the answer already, because it is a common name that even non-chemistry students are familiar with. However, we should learn the process of deducing the name carbon dioxide from what we have just learnt. The first element appeared in the chemical formula is carbon, the second one is oxygen. Since oxygen is at the end of the formula, after taking the first part of oxygen and adding IDE, we have oxide. Then, we see that there are 2 oxygen atoms and 1 carbon atom in the chemical formula. It is no need to write the prefix mono before carbon because it is the first element appeared, so we have carbon. And the prefix di is added before oxide to indicate there are 2 oxygen atoms in the chemical formula. As a result, we get carbon dioxide as the name for CO2. Remember that there is a space in the middle. Let us have one more drilling exercise, N2O. The first element appeared is N, and the second one is O. Since O is at the end, so we take the first part of oxygen and add IDE to give oxide. Then we see that there are 2 nitrogen atoms and 1 oxygen atom in the chemical formula. The O is not the first element appeared, so we add the prefix mono to indicate 1 oxygen atom. Add the prefix di to indicate 2 nitrogen atoms. Because of the grammatical concerns, we have to delete 1 O when the prefix mono is added to oxide to give monoxide instead of monooxide. Therefore, we have dinitrogen monoxide with a space in between. Up till now, we have finished the discussions on chemical naming of compounds not containing metal atoms. Then I am going to talk about the chemical naming of compounds involving polyatomic ions, which I have mentioned its definition above. Basically, the methods are the same with that of the first and second categories of compounds. Note that we seldom change the names of polyatomic ions. Each ion has its own name. Here are some common examples of polyatomic ions, such as PO43-, phosphate, SO42-, sulfate, NO3-, nitrate, CO32-, carbonate. However, if the given polyatomic ions have any differences as compared with the above listed examples, such as having 1 oxygen atom more or less, we have to first change the name of these polyatomic ions before naming the compound. For naming polyatomic ions containing oxygen atoms, the most common species is named with ATE at the end. For polyatomic ions having one oxygen atom more than the most common species, the prefix per is added. For polyatomic ions having one oxygen atom less than the most common species, change ATE to ITE. For polyatomic ions having two oxygen atoms less than the most common species, change ATE to ITE, and add the prefix hypo. It's time to do some drilling exercises. The naming of Na2SO4. The cation is Na+, sodium, and the anion is SO4 2-, which is named sulfate. Simply combine their names without making any changes to the second part. The answer is sodium sulfate, with a space in between. The second drilling exercise is FeNO3 bracket 3. The cation is Fe3+, so the first part is ion 3. The anion is NO3-, which is named nitrate, so we get ion 3 nitrate. One more drilling exercise, Na2SO3. The cation is Na+, sodium, while the anion is originated from sulfate. The polyatomic ion, sulfate, is SO4 2-, but now we get SO3 2-, which contains one oxygen atom less than sulfate, so we change ATE to ITE. Finally, we get sodium sulfite as the answer. Alright, we have finished the discussions on chemical naming of simple ionic compounds. If you want to learn the chemical naming of other compounds, please refer to the corresponding videos.